Hello, everyone, and thank you for joining today's FastCast, the cell-free technology that's dropping GPS costs. This is Robin Klein, Director of Marketing at Lat-Lon, and I will be your moderator today. Our presenters today are Michael Finnegan and Dave Baker. Michael is the IoT Business Development Director for MultiTech, a leading technical design consultant and public speaker focused on engineering, design, and commercialization of embedded systems for the Internet of Things. His 19 years of experience in designing enterprise wide area networks and cloud infrastructures has helped hundreds of customers and partners deploy thousands of devices. And Dave Baker is president of Lat-Lon, a BSM technologies company, an aerospace engineer spending the first half of his career at NASA's Jet Propulsion Lab and then Martin Marietta. He's co-founder at Lat-Lon, established in 1999, now a BSM technologies company, and developed the coveted algorithms behind the delta velocity, G-force filtering, and graphing visible to hundreds of customers today. After the conclusion of today's formal presentation, we will have a live question and answer session. Please submit your questions at any time by typing them into the Q&A panel on the right-hand side of your screen, and be sure to send your questions to all panelists. Our presenters will be answering as many questions as time permits, and we'll follow up offline with any questions they're not able to address during the live event today. And we will also be distributing the presentation itself shortly. I'll now turn it over to Michael.
Thank you, Robin. I appreciate it. I really appreciate to be presenting here with Dave Baker and with the Lat-Lon team. Excited about what's going on, and I'm pretty excited to see that my name is right on the railroad tracks here. It reminds me of that Will Rogers quote about regarding success. You may be on the right track, but if you don't get moving, you're going to get run over. So with that, we have about 30 minutes to go through a lot of great content about some new technologies, and I'm looking forward to sharing some great ways of deploying some new technologies in this area and industry. So to get started, let's talk a little bit about some of the challenges that are happening out there today. Internet of Things is a rapidly growing market, and many people know that. We'll talk a little bit about just how fast-growing it is. But I'd like to look at these things a little bit different. Instead of just looking at them as things, but as objects, of being able to acquire data and be able to bring them into market. And we share some challenges, whether you're using cellular or using long-range RF or other types of connectivity. They share some common attributes here. Or challenges, right? So battery life is usually a pretty big thing for constrained items that are in remote areas. And, happy to know that, Lat-Lon has really solved a lot of those challenges around battery life with energy harvesting and other solutions. But also looking at outdoor harsh environments, looking at cost as a major objective to resolve, and then also looking at robust communications and that allow for mobility, and then also the ease of use. More importantly, it's a really highly fragmented market. So what's the best way to be able to deploy something and to make that happen is really what we're here to talk about today. So let's look at some, what I would say is some old friends here, and looking at connected devices and the access types that we have. So many people have looked at using short-range technologies. LAN technologies like Zigbee, Bluetooth, or BLE, or Wi-Fi. These are great for really good mobile applications, sometimes within home or within a particular area. And they're really for short range, but they're not really good for battery life or for long-range type solutions. Then we have our cellular applications, which really have targeted really well in this industry, in rail specifically. And, so everything from GSM to 3G and HSPA plus and CDMA technologies and 4G technologies that have come on the scene recently. And so those are really good for long-range solutions and high data rates and coverage. So, see these as really good options for this other area to hit the long range. But there's a drawback to these. They actually have, they're not so good on battery life. If anybody's been carrying around their phone for a good portion of the day, you're always seeking to find a way to plug it in. Then we have this new category, low-powered wide area network, or LPWA technologies, as we'll refer to it later on. We have lots of new players in this area: LoRaWAN, Sigfox, Ingenue. These are several of the categories that are. We're going to talk a little bit specifically about these. These are really good for long-range solutions, long battery life, low cost. And then, but the one thing that you have a trade-off here is that you won't have a really high data rate. So these are not great great technology for high bandwidth solutions like video conferencing or something like that. So you have to really pick the right technology or access type to make it work. So let's review a little bit of what some of these access types might be. So this is a great little slide that helps kind of present some of the options that you have out here. And when you're looking at this slide, around the midpoint, take a look at right inside here. Let me get my pen. Right around the midpoint here, we're going to see a differentiation between, unlicensed spectrum using the ISM bands, and then below it being licensed spectrum technologies using cellular type of communications. And we started, pretty much for the first time in the history of telecommunications, LTE has come on the scene, kind of giving us a world view, or maybe for the first time a standard that can be used. The challenge is that it was really quite high bandwidth, and the cost was relatively high. So we started seeing other technologies come on the scene, and looking at these ISM bands, or low-powered solutions that came in the market very early in 2014, and those are dominated by Sigfox at the low end, being kind of a lower bit rate. LoRaWAN in hitting between that about 300 bits per second, all the way up to about 56 kilobits per second. And Ingenue and Wi-Fi picks up these other technologies that go from up into the upper 100 kilobits plus category. And then we have the other type of technologies like Bluetooth and Wi-Fi that pick up even larger bandwidths, kind of more LAN type technologies, if you would. But now what we're seeing is an interesting phenomenon where cellular is starting to come down using low-powered wide area network into this ISM bands, or into the same bandwidth capabilities here. This is a really unique piece for us, because now we're starting to see this complementary between unlicensed spectrum and licensed spectrum. And really, I kind of see these as complementary, and really just opening up the market for new ways of deploying technologies. And Dave will get a chance to share a little bit about why we're seeing low-powered wide area network, and specifically LoRaWAN taking off in this industry. So let's move on to the next slide. So growth is going to be huge in all these categories, and whether you believe the statistics from IHS Insights or ABI Research, I think we're all trying to figure out exactly what the girth is going to be looking like in the future. But as hardware manufacturers, we have to look at where the industry is leading and where they're going. And what we're really seeing here is a real trend towards high growth in both unlicensed spectrum, or LPWA technologies, as well as cellular. And so both of them have this really hockey stick curve they're coming up. But some of the deployments that you'll see that'll happen out there will be in LoRaWAN, some in Sigfox, as well as Cat-M and narrowband IoT, and they all have their own specific growth curves. So let's talk a bit about LoRaWAN. So LoRa stands for long-range RF, and when we start looking at where it fits in the marketplace, you have Bluetooth at the range of between, let's call it 30 and 50 feet range. You might be able to get a little bit longer with some newer BLE applications, but for the most part, it's meant for pretty much short range. Wi-Fi is another great short range type solution, and that's somewhere between, say, 100, maybe up to 250 feet, depending on where your positioning of your access point is. And so this is a good technology for being able to aggregate within the region. And then there's this other one called Zigbee. Zigbee also has a 900 type radio solution, that goes up to about 1,000 feet. But it has a couple little drawbacks in that it usually uses a mesh technology to propagate the signal, and every node has to take power. So great solution in today, but has a couple drawbacks from a management perspective. Frequency shift keying, or FSK, is another technology that's used and really helps deploy in solutions that are up to about 2 miles. It also has some drawbacks, being in narrowband, that it could be stepped on by noise and interference in its narrowband. So here's what I think is kind of an interesting thing is we see LoRa, or this long-range RF, or LoRaWAN, which is one of the standards today. is a complement of both using LoRa technology as well as a frequency shift keying option. And its modulation scheme can hit up to about 10 miles in range. What we're seeing in practical applications is a good 5-mile deployment range. And we'll talk a little bit about that sensitivity in just a little bit. So let's talk a little bit about the modulation. And what's being used here. So LoRa is a chirp spread spectrum technology, and it uses the entire bandwidth or the entire signal wave here. And one of the unique characteristics about LoRa is that it operates below the noise floor. And this is a unique thing so that we can be able to deploy in environments that are very harsh and maybe very noisy and be able to still get the signal through. In addition, it has better sensitivity than just straight frequency shift keying. So we can actually deploy in an FSK mode within an environment to do indoors and get up to 2 miles and have a really good sensitivity to it, and also be able to avoid some interference, noise, and other jamming. So it's a very robust technology. And lastly, I think one of the areas that's most unique about this spreading factor is that it can actually have simultaneous occupation on the single channel at the same time, as long as there's different data rates that are happening between this. So it allows you to be able to deploy in some unique areas that might be in both a public or a private environment, or be able to share multiple networks within the same geography using this ISM band or what's also known as free spectrum assets. So let's talk a little bit about bandwidth, and then we'll probably give a practical application and then show how this rolls out in architecture. So the chipset that's being used is called the SX1272 chipset, and it supports 3 bandwidths throughout. And so these bandwidths are used simultaneously to communicate the information. This improves kind of the data integrity that's out there. So we've got 3 different bandwidths in Europe. What's popular, or the specification supports 125 kilohertz, 250 kilohertz, and 500 kilohertz. In North America, through the FCC, it supports only 125 kilohertz as well as 500 kilohertz. These multiple bandwidths allow for multiple data rates to happen at the same time, using spreading factors to make that happen. So let me give you an illustration of how this works. So we have a base station and an antenna that's in a fixed location, and then we have nodes that may be anywhere in a distance 5, 10 miles, sometimes even greater, depending on how high your antenna is. And based on that, the base station is going to radiate out, and throughout, we're going to have various spreading factors that you could be able to connect with. And during those spreading factors, depending on where you are at in relationship to the base station controller, you'll be able to lock in on those spreading factors and be able to get a specific data rate and have a specific, receive sensitivity. And as you move, you may be able to change the number of spreading factors that you use and the amount basically in the data rate that comes in. So this is how it works. The closer you get to the antenna, the more bandwidth you get. The further away from the antenna, the less bandwidth you get. However, what you'll notice, though, in this graph is that the received sensitivity is very good, so that you can actually get a very long range and still be able to get, your data, albeit, somewhat constrained at 292 bits per second. But as you get closer to the tower, you'll start to experience more data bandwidth because you're using more spreading factors. That's essentially how it works. So let's talk a little bit about LoRa and the Alliance. So the LoRa Alliance was formed in 2015, and this is for this ISM band, the closest thing to a standard that's out there in the industry. So, and this is a very fast-growing alliance. Over 400 organizations worldwide contribute to the standards or to the standardization of LoRaWAN. So everybody contributes to create reference designs, and these reference designs are adopted so that you can have interoperability between hardware, between nodes and base stations, and a common set of standards that you can be able to communicate from security layer all the way up to how you're doing the various key management capabilities. More importantly, it's a common understanding across all these companies on how we're going to communicate and roll out these technologies worldwide to support, the industry in lots of different ways, including taking where the standards stay today and where they're going to in the near future. So the LoRa Alliance is a very important part of the adoption of this technology. So now that we know a little bit about the standards or a little bit about where the Alliance is going, what you should know is how it's being deployed on a worldwide basis. So LoRaWAN is an effective way to be able to do this. It's primarily has two main deployment options, either in a completely private environment or a completely public environment. So we're seeing brands and various companies like Lat-Lon create a private infrastructure and a private way to be able to deploy. This is great for low OpEx type solutions, very data protection and speed deployment. You can really lock in on this. And on the other side, we're seeing carriers deploy large networks to look at macro network capabilities. But what we're finding is that enterprise customers have a hybrid approach where they may take advantage of private as well as public type capabilities. So let's see how this looks like in an architecture, and then Dave is going to hand us into how this deploys into products. So the architecture looks something like this. You have nodes on the far left side. These have interesting applications. Could be temperature for refrigerated rail cars, impact alarms for as those trains come together, looking at speed, maybe looking at maintenance options, safety and security, or maybe tire pressures for once those containers go onto the long-haul vehicles. All these applications have nodes, and these nodes communicate up to basically the base stations. And here are some of the MultiTech products out there where we use an industrial type gateway, an IP67, and then an access point that might be deployed inside here. We deploy this architecture where the nodes can communicate directly with the gateways. And since it's a standard, the nodes can be interoperable with other manufacturers as well as the gateways. The signals are aggregated up through with security with AES encryption from the end node all the way up through the application layer. So it's a highly secure communication. What's interesting is the applications themselves have the ability to have the LoRa join server locally, or optionally you can bring this up into the cloud. So it's a really good model for both private deployments as well as moving to a carrier-based model or a hybrid in between. What's important to note in this architecture is that the data is not necessarily owned by the service provider. And so that basically the data can be brought out to many different visualization platforms, so if an enterprise needs to go to a specific cloud. So this is the architecture, and now I'm going to get a chance to hand over to Dave to talk a little bit about how these relate specifically to rail and to the products. So Dave, off to you.
Well, thank you, Michael. That was an excellent overview of the LoRa technology, and I promise everybody there won't be a quiz at the end because I don't know if I could pass it, but that was really in-depth and excellent. So thank you again. At Lat-Lon, we've been doing rail monitoring, GPS tracking for well over 15 years, and one of our biggest challenges has been the number of different modem types we've had to put into our product. I think it's over 15 different modems we've had to deploy. And so we're really excited about this new technology of LoRa because we can finally put in some modems for the right applications where we can put them in and they will last as long as the product lasts for, up to a 10-year period or longer. Without the GSM network coming down, or 2G, or then the 3G, and all that sort of thing. So we're really excited to be part of the world of MultiTech's LoRa and the LoRa Alliance, and to be able to put that into our product line. So what does this mean in the rail application? Lat-Lon has been involved in generating monitoring data that includes just basic GPS tracking, accelerometer data that creates overspeed coupling, speed logging from the GPS to see how fast a car was rolling in a yard before it slammed into another car, and then coupled, possibly disrupting the contents inside the car. Temperature monitoring, hatches opening, handbrakes, all the different things that you can monitor in a rail car, and we even have a camera solution that can take day and infrared night pictures. So one of the interesting things for us in this market is the rail industry. We look at it as an upside-down wedding cake. It's narrow at the bottom, it gets big at the top, and at the bottom you have things like refrigerated box cars, locomotives that are obvious targets to afford the cost of a cellular data plan and the hardware to monitor how those systems are performing. But as you go up into the wider parts of the cake that get up higher, upside down, you get into things like coal cars at the very end, and you struggle with the ROI, the return on investment of paying, say $10 a month for that coal car times 100 cars per train times many, many trains gets into a lot of money. And so we've always been looking for how can we access more of the market, and so to us, LoRa is a breakthrough that gives us a market expansion of giving the ROI numbers that are suddenly positive and make it work for these other assets in rail. And so because of the nature of the coverage up to 10 miles, it's not going to have visibility as you move across the rail line like the cellular solution we also offer does. But for certain applications, it works just great. For example, a maintenance facility that might have a couple-mile-long yard to hold the cars to be worked on, and the cars that are finished could all be lit up by one gateway. And so that's a very compelling application, is everything would be coming in live from such a yard. The other big application we see is where cars from a plant where the cars are loaded and the plant owner owns the rail cars, they go out, they get loaded, they're live within the plant from the gateway, then they leave and they are not live, but they data log, and all the data of where they are and impacts and pictures and speed profiles is logged away in the memory in the unit, and then when they come back from their delivery to their customer, they dump all that back down automatically, wirelessly, and all that data gets backfilled. So let's see here. Now, of course, the lower data costs. Let's plunge into that a little bit. We have a small data fee that we still charge to cover the data warehousing and our user interface, basically the presentation of the data. It still requires a little bit of cost. But this change of price really changes the whole picture. So let me give an example here. We have, with the LoRa, well, I'm going backwards here. So with cellular, you'd be, something like in the $10 per month for the data service. Well, for a 7-year life, that works out to $840 just in data costs. Well, that's likely more than the equipment you purchased. And so the total cost of ownership then gets to be over $1,000 in that range. With the LoRa, then, we're talking about essentially 1/10 the cost or less at 84 cents a month. And so for 7 years, that's only $70 of data cost. And that could just be rolled into the hardware purchase up front, and you're done. You don't have to pay any more as you own the product. So let's look at the hardware that Lat-Lon is offering. Obviously, there's the LoRa gateway shown there at the top with an antenna on top of a mast and the backhaul antennas for the LTE. This can light up a yard. It would be installed at a central location, and the higher the better, as Michael had discussed. When you buy that, then you're ready to go, and you can buy multiple gateways. You might even talk your customers into installing gateways at their facilities so that when your shipments arrive there, they go live again and everything gets backfilled data-wise. Now, we have two products. One of them is our legacy product, the Solar Tracking Unit, or STU, which is the triangle box in the middle there. And that is a high-capability solar unit that is able to run the GPS continuously with the power it harvests which means all your data is live time-stamped. There's no delay between when something happened and then when you finally get a GPS fix. And then if it's in the LoRa coverage zone, it'll immediately transmit the data out. And also, you can transmit data to the units through the LoRa. It's a bidirectional pathway. We can push new firmware to our products, push configuration settings and so forth out to them. And then we developed a new product called the LoRa Micro Tracking Unit, or MTU. At the bottom there, it's so small it's hard to see on the slide. But what that is a little 3x3-inch cube. We have the nickname for it of the cube. And this is a GPS-only LoRa-equipped tracking unit. It doesn't have the cellular option like the STU does. The STU can be LoRa or cellular, but the MTU is just a LoRa product. It has our lithium iron phosphate batteries in it, same as the STU, for a very long life. And so that would be an ideal application in a yard where, say, you want to just track stuff as it comes in and then pull them off as they go out. It's got a magnetic base mount to it. You just slap and track, put it on, pull it off, and it's not going to take boxes and boxes of inventory. So what kind of data do you get when you enter the Lat-Lon world? And this slide shows a collage of some of the things you get. Obviously, there's the breadcrumbing of GPS locations on a trip or the entire fleet spread across North America. On the lower left shows impact graph with the analysis tools we have to change the filtering levels dynamically with the data that's come in. 500 hertz data, so you can change your filtering on that and smooth it out post-processing wise. Lower right is some temperature data, and we have not shown our pictures from rail cars that we can take. And of course, we have the mobile apps for Android and iOS, where it's not the full user interface of the web, but it's the basics of a map and a report of where my equipment's located. So that is the end of my presentation. Looks like we're at about half an hour in, so I'm going to turn this back over to Robin.
Well, we do have a question about the security of the transport method or of LoRa, I believe. If I could kick that over to you, Michael.
Sure, I'd be happy to. Thank you, Robin. So if you wouldn't mind, since you're in control, could you jump up to slide 15? That would probably be a great way to give a picture and answer to this. So the unique part, so I get this question a lot, since it's using the ISM band, which is unlicensed spectrum. People naturally start to feel like, are they at risk? What's unique about the LoRa solution and the LoRaWAN, Semtech is the chip manufacturer and the patriarch of the technology. And has licensed this out. Part of that solution is what's called the LoRa MAC. And at the MAC layer, which kind of communicates both at the RF and at the hardware layer, there's encryption. And encryption, it's a 128 AES encryption that takes us from the end nodes all the way up through the application layer to the join server. So the devices have multiple layers of security inside here, starting with the encrypted path, but also has many layers of key management and identity management down to the hardware layer, using an identifier, using the LoRa radio itself as it communicates to the join server, as well as key management. MultiTech has taken the step a little bit further to actually add an additional layer of hardware identity management by putting an eSIM option onto our nodes, our communication nodes. So if security is a real concern, we've added that identity layer at the hardware layer to help support that. So AES encryption is the answer with key management that's built into the LoRa specification or LoRaWAN specifications. So if they need some additional information on that, feel free to let me know if there's a follow-up question on that. Thank you. Great question.
Thank you, Michael. Another question, I believe this is for you, Dave. In the case of moving railway trains, where does the concentrator or gateway reside on a locomotive? ?
Thanks, Robin. That's an interesting question. there are actually two ways to implement the gateway. One would be a fixed solution like I described earlier, but there's also the other solution to put the gateway on a locomotive pulling the cars that are equipped with the LoRa units. And so in that scenario, the coverage circle, if you will, goes with the train and you are always live.
Thank you, Dave. And is there, sorry, one second, is there an API to pull Lat-Lon data and utilize with other applications such as employee staffing software, alerts on predictive crew scheduling?
Yes, that's a good point. We do have many customers who pull our data on a 1-minute interval or some such, and roll that data into their back office system, and then they can incorporate that into SAP or similar and assign all kinds of other information such as crew shifts, their customers assigned with the shipments, and so forth. We also have the ability to go the other way and to have some data pulled into our system so that company proprietary data can be added as fields to the reports at our end, although that's a more limited approach because we don't want to be taking too many pieces of data on a unique basis from each one of our customers.
Excellent, gentlemen. Thank you so much for all that you've contributed today. We really do appreciate it. And now I would just like to remind everyone that all of our attendees will receive a copy of the slides within the next 48 hours. Unfortunately, we don't have them downloadable today, but there also will be a recording of this Fastcast if you want to listen in again on our website at Lat-Lon.com, or visit us at the Interchange booth and speak with Dave himself, booth 3452, or if you need our contact information. We look forward to hearing back from you.